The video I have made is to explain my hypothesis for galaxies and other celestial objects to be planar. Here I have a button tied with a string. Your button acts as a mass tied to this small string. Now let's try rotating this button. So as you can see, as it rotates, it's pushed outwards. It experiences a force radially outwards. When the bead was stationary, it was just lying down. But when it was rotated, it took a circular trajectory. In a plane, right? Why it happened? It happened because of a centripetal force, Fc, which is equal to mv squared by r, where m is the mass of the object, v is its velocity with which it is moving, the angular velocity to be precise, and r is the radius of trajectory. So this is the force which causes this bead to spin, and it experiences an outward, radially outward force, centrifugal force, right? So this centrifugal force exists because of the rotation. So centrifugal exists because of centripetal. This is the reason why bead was just forced radially outward. And similar is true for our planets of solar system. They rotate around to maintain their position in the orbit. So they experience a centripetal force. Here, centripetal force is our gravity, the sun's gravity, which holds these planets towards it. And centrifugal force helps them save themselves from getting bombarded to the sun. Now let's look about galaxies. What causes them to spin, or what causes them to be a plane? Galaxies, as we know, are big structures, just like structures, having supermassive black holes at their heart center. So this supermassive black hole engulfs all the matter around it and making things around it spin in a circular path, and this end up inside the black hole. And this causes the things around to spin, and eventually the galaxies also spin. But we don't get to know. Why? Think about it yourself. Suppose you have an infinitely long, big, large disk, and you're standing somewhere very near to it. Right? It's kind of very large that the distance is quite small compared to its diameter or radius. And there's another person standing with you, maybe your friend, and you hold a rope which is not stretchable, it's not elastic, it maintains its length as it is. So when this thing is being rotated, will the length of the rope change? Yeah, you'll be experiencing a force outwards as we saw in previously, but the distance between you won't be changing, right? It won't change. And you'll find that person is rest with respect to you. You'll find that the person is not moving, but actually you are also moving. This is the relative motion. And this is because the observer, that is you, is also in motion. And you are seeing that person respect to you. So you both will find yourself to be at stationary. Similarly, like when you are moving in a car, the person sitting beside you seems to be stationary compared to the trees outside on the road which appear moving. But actually, trees are at rest and you are moving. So this is similarly like that. Now this could raise a question. Is our universe also spinning? There are some experimental data and kind of stuff saying that universe is not spinning. But wait a second. We use big telescopes to watch distant stars and galaxies and other celestial objects. So we are observing respect to our motion of Earth. So like in previous case where you were also part of that big disk, our Earth will cool be the part of that big universe which is spinning, and we are looking those things with respect to our motion, our relative motion, and which may and make us things appear that they are stationary, they aren't moving, only we are moving, right? So there it's possibility of universe to be spinning,